Hello guys, hope you are doing well. This is me, Mubin, your physics teacher, and you are watching Physics by Mubin. So we have done the numericals, the past papers, the topics about momentum and 2D collision. Now the major topic is forces. All of you know what is force. It is the ability to move a body, to stop a body, to change the direction of a body. This is the questions of O levels. Okay. Now moving to A level, we should know about force. That force is a vector, okay, and it cannot be added by simple methods, okay, simple methods. So there are two methods to add vectors or forces. So the thing is, we are talking about vectors for now because force is also a vector, so rules are the same. Okay, how to add vectors? One is graphical method and the other is you can see that algebraic method. What is the graphical method? The graphical method of adding vectors is called head to tail rule. Head to tail, sorry, it is tail, not fail. Head to tail rule. Okay. What does this head to tail rule suggest to us? Okay. This states that first, if we are given with two vectors, suppose that this is first vector and this is the second vector. You are to draw the same vector such that the tail of second vector collides with the head of first vector. Okay, tail of next vector collides with head of previous vector. Okay, yes. So draw these vectors such that the tail of the first vector is collided by tail of the next vector. Now, join the last vector such that head collides with head and tail collides with tail. Okay, this is called head to tail rule. Okay, let me elaborate it next at once. First, consider this. We are given with this vector, and this vector. These are three vectors of equal magnitude. Suppose this is 1, this is 2, this is 3. So how we are going to add them? This is the first vector. We are to place second vector such that its tail collides with the head. We are to place the next vector such that tail collides with the head. Okay. But the thing is, for the last vector, for the very last vector, we are to make it straight. Like the tail with tail and head with head. Tail with tail and head with head. This is only for the last vector. For the last vector. Okay. Hope you have understand it. Moving for the next page. Uh, what is the numerical or algebraic method of the vectors together? Algebra, vector algebra. See, if there is a body, if we apply force in this direction, where does the body will go? The body will move in this direction. If I apply force in this direction, the body will move in this direction. If I apply a force in both of the directions, where will the body go? It will go in this direction, making some angle. Okay. If the thing is, if these forces are equal, these forces are equal. So the body will move exactly at center. If this force is greater, the body will move in this direction. If if this force is greater, if the y-axis force is greater, the body will move in this direction. Okay, so what is the deal? The deal is, if a body is moving at any of the angle, it means that there is some force in this direction and there is some force in this direction. Are you getting me? Okay, there are two forces. There are always two forces of a force. This is force in x-axis. We can say that f of x. This is force in y-axis. We can say it f of y. Okay. So the deal is how we are going to find f of y and f of x. What are the values of f of x and f of y? See, if the force is like this, it is making a theta angle. It means that there is a force fx and there is a force fy. Yeah, I know this is not a right angle triangle, but please compromise on me. So f of x is always equal to f cos theta, and f of y is always equal to f sine theta. If you don't know how these equations are formed, please go to O levels and find this, because if I am going to explain this in this video, so the video will take too much long. Okay. And how we are going to find the resultant vector? We are going to find it by under root fx square plus fy square. And how we are going to find theta? Theta would be equal to tan inverse of fy upon fx. But this is not the great deal. The deal is how we are going friction. What does friction means? Friction is a contact force, contact force due to what? Due to the irregular surfaces, due to the irregular surfaces. Okay. There are two types of friction, majorly. One is static friction, static friction. The other is dynamic friction. Okay. One is static friction, the other is dynamic friction. The static friction is always greater than the dynamic friction. Okay, let me elaborate. If you are having a car, what is easy? Is it easy to make it move, or if it is moving, it is easy to make it more faster? What is easy? To move from rest, or move from, or fast from previous. Okay, what is easy? Yes, moving faster is more easier than moving from rest to some velocity. Why is it? See, see. How is friction formed? First of all, you have to notice. Everybody is like this if we zoom it. And the other thing is, it is like this if we zoom it. Okay? Now, if this body slides on this body, then there is a force between these pores. This is called friction. Okay. So moving forward, the thing is, for static friction, if we make a force applied, if we make the force applied and the force of friction graph, the graph would be like this. If we increase the force, the friction will increase. If we increase the force, the friction will increase. This will happen until a limit. This is called static friction. This is static. But if we apply more force, the body will start move and the friction will decrease. It is dynamic friction. Okay. Dynamic friction. Let me elaborate. Static friction is variable. Static friction is variable. If we apply more force, the static friction will increase. If we apply more force, the static friction will increase. But to a certain value, it will increase and then it will decrease and becomes dynamic friction. You have noticed it or not? If there is a block, apply a very little force on it. It will not move. Now increase that force. It will not move. Now increase that force. It will not move. Okay? It means that force of friction is equal to the force applied. But if you apply the force too much, it will start moving. It means that now the force applied is greater than the force of friction. This is because it is dynamic. Okay? So moving forward, the thing is relation of friction. Relation of friction. What is the relation of friction? If you know that there is a block, there is a table. It is a weight. The table applies a force that is called normal force or reaction force that is equal to weight. The force of friction denoted by small f is always directly proportional to the reaction force or the weight. Okay, if I apply a constant that is mu r, force is equal to mu r, and mu is equal to force of friction by r. Okay, this is the relation. What is mu? Mu is the surface constant, and it is constant for all surfaces. No, for every surface. Okay? Mu is the ratio of force of friction to the reaction force. Okay, friction doesn't depend on surface area. Friction doesn't depend on the force applied. Friction only depends on what? It depends upon the weight of the object. Sorry, it only depends upon the mu. It only depends upon the mu. Okay. Now, friction on inclined plane. Friction on inclined plane. Now watch this. This is a plane over here. We know that the weight is downwards. If if this is the angle theta, the opposite angle would be theta. Okay, if this is the angle theta, this would be the angle theta, and these both angles are equal. Okay, now if this is w, what is the angle with theta? It is w sine, sorry, w cos theta. And what would be this angle? This would be equal to w sine theta. Have you cleared it? Okay, let me do it again. I will explain you again. If this is an inclined plane with the angle theta over here, the weight is downwards. It would be angle theta and it would be w cos theta and it would be w sine theta. Okay, let me just reverse the game. If I know my diagram, if this is angle theta, it would be w cos theta and it would be w sine theta. So, in this case, the force of friction will be always opposite to the moving object. It will be always opposite to moving object. So, friction would be equal to W sine theta if the body is in uniform acceleration, sorry, uniform velocity. So, the force and W sine theta would be equal. Are you getting me? This was the force in inclined plane. We will do some examples of friction and the forces and their components in the next lecture.